Okay, because of in a resistor also, we can connect a resistor in two ways. We can connect it in a series connection, and can connect it in a what? Parallel connection. That is what I was saying in the group. But because of I discovered that if I should continue discussing about it, it's going to be too long and difficult for us to really understand. So that was why I decided to skip discussing about anything in the group. So now, series and parallel connection. Let me explain it properly. You know, I said it that last time in listen in the last class that if you connect your battery in series, the voltage is going to what? It's going to increase. But if you connect your battery in parallel, voltage is going to be what? It's going to do the same thing. Same thing as a resistor in series. If you connect your resistor in series, the resistance is going to increase. Something like this. Let's assume this is resistor 1. This is the first pin, this is the second pin. This is now resistor 2. Resistor 1, R1, this is how they should label it. R2. This is the pin 1 of resistor 1, pin 2 of resistor 2. Pin 1 of resistor 1, pin 2 of resistor 2. I'm going to do a practical showing you how the resistance is going to increase in real life. Now, you now take this pin 1 on, the pin 2, you now take this one, you join two of them together. Let me use a red marker so that it can be clearer. You now take this, you now join two of them together. You merge the two of them together. It's now leave only this place and this place. Now this is a what? Series connection. In this point in time, the total resistance is going to be R1 plus R2. If you take another resistor 2, you combine it together, you use another chain, you use to form another chain like this. The output now comes to this place. You now label it R3. It's going to be called plus R3, and so on and so on. This is a what? Series connection. And this is going to increase is that at this point in time, as I said earlier in that electronics part, let's assume we are having a car passing. There's hold up here, there's hold up here, there's hold up here. This is the starting point, this is the end point. Now look at what is going to happen. If you pass through this road, there's hold up. Oh, there's much of hold up here. You pass through this one again. You must have to pass through the whole road to come to your destination. And also you must pass through the whole road that has what? Resistance or what? Hold up. What's going to happen? You're going to experience that the hold up you're going to feel is going to be very what? Much. That was why the resistance is going to what? Is going to increase. Sorry, I'm coming. That is why the resistance is going to what? Is going to increase. Unlike in a parallel connection, which I'm going to be describing now. But before I discuss about a parallel connection, let me show it to you guys live, a series connection. I'm going to be using my multimeter. Now I have two resistors, and the resistor that I have are what? 1 kilo ohms. Where's my marker? I have two resistors, and two resistors are what? 1 kilo ohms. 1 kilo ohms. 1 kilo ohms is the same thing as what? 1 times 1000 ohms. So it's the same thing as 1000 ohms. So this is multimeter wire right here, and this is my resistor. This resistor is one. Okay, this is not 1 kilo. Okay, this resistor is going to give us is 1 kilo ohms. So everybody, please, are you seeing it now? I want to place my multimeter pin. This is the minus of my meter, the black, and this is the plus. And what do we see? What is it showing us? What is it showing us? Yeah, 0.96, which is approximately 1. Yes, and if you see it, it's showing, yes, 0.96, there's kilo ohms. 0.96 kilo ohms. And this is why it's not up to 1 is that human beings are not perfect in doing things. There's possibility of us getting high 1 or lower than 1. So this is 1 kilo ohms. So this is another one here. This one also is going to give us 1 kilo ohms. Or in ohms, some professional engineers, they don't need to use their multimeter. It has a color code on it. If you can see, there are some colors there. That color is being used to identify it. But sometimes the best way to use your multimeter. So this is it. what are we have? Can see that this time around we are seeing 1.0, but in that previous one we saw 0.9, but all of them are close to what? 1 kilo ohms. And to show you that it does not have positive or negative, let me swap the wires. So we are still getting the same value. So that is one, yeah, 1 kilo ohms. So now as I said it, this is resistor one. This is resistor one here, and this is resistor two. So I said it that okay, let's say this is pin one, pin two of resistor one, pin one, and the pin two of resistor one. So let me join all them together to form that series connection. So look at them, what the total resistance we're going to be having. I've already joined it together. What will be the total resistance? Hmm? Okay, the next I might be, and you might be talking about, I might not be hearing you because of the network. But total resistance is going to give us close to 2 kilo ohms. So let us see. So let's say the magic here. So can you see? It's giving us what? 2 what? 2 kilo ohms. And that is because of what? They are connected the what? Series. They are connected the what? Series. Are you guys getting it? So now see we are getting it in what? 2 kilo ohms. The reason why it's not perfect is the resistor is not perfect. That's why the value is fluctuating. But it's giving us what? 2 what? Kilo ohms. I have another 1 kilo ohm. Oh, I don't have another one. But as you can see, it's giving us what? 2 kilo ohms because of what? They are connected in what? Series. So mean that if you connect a resistor in series, the resistance is going to do what? It's going to increase. So that is that about that. So I'm going to be doing a parallel connection, but let me explain it on the board also. Let me loosen it for using it for the next class. So now let's go back to the board. Okay, so can we continue? Can we continue? Okay. So now that is that about it. What? Any question? So that is that about a what? Okay, that's that about a what? Series connection. So now what is now a parallel connection? You know I told you that resistor one has this to this place. This is pin one, pin two, resistor one. You now have what? You now have resistor two, pin one, pin two. Now in a parallel connection, just like a parallel battery, that means in a parallel connection of a battery, you connect all the positives together, all the negatives together. But in a resistor, in a parallel connection, you connect what? You connect all the one together. You connect what? All the pin two together. If you have another resistor again, you bring it inside. Everything you connect the ones together, so now form a what? You form a what? Junction. You form a what? Junction. So you can now bring it as your output, or you can use here as your output, this place and this place. You can use anywhere. You can even put it here, output one, and use here as output two. Because of all of them are what? All of them are connected together. But yeah, the resistance is going to reduce because of what? Let's assume that the car is driving. The car will be like, okay, if I pass, let's say there are many cars, like three car, the three car will be like, okay, if I pass here, there's going to be hold up. If I pass it, there's going to be hold up. If I pass it, there's going to be hold up. Instead of us passing here at the same time, let us do like this. One car should pass here, car one should pass here, car two should pass here, car three should now do what? Pass. All of them will now come outside. Come outside and do what? Come outside the same place. That is to tell you that what? Resistance is going to do what? Resistance is going to what? Reduce. And the current is going to what? Split. So now, what's now the formula for the resistance of a parallel connection? That means this is a parallel connection. Parallel connection. This is the formula. The formula is 1 divided by the total resistance RC is equals to 1 over, don't forget about the formula, 1 over R1 plus 1 over R2 plus 1 over R3 plus whatever resistors are there. Everything will be 1 over this thing. So let us do some little maths. We have 1 over RC is equals to the total SCM is going to be this times this times this. That is R1, R2, R3. I've already multiplied them. That means R1 times R2 times R3. So now it will now be okay. Let me make it simpler. Let me remove one of this guy over here. Let us make it simpler. So don't worry, just forget about the mass. Okay, if it's problem. So it's going to be this divided by this. We're going to have R2 plus R1. So that is that. So what's going to happen? But we cannot be doing okay, what total resistance? Total resistance is going to be this plus this over this. After I get it, now start find the inverse of the answer. No. We'll now do something like this. The total resistance RT is going to be what? Bring, since we already make this one upside down, let's make this one what? Upside down. R1, R2 over R2 plus R1. So this is tell us that the total resistance of a resistor in parallel is going to be this, the first resistor times second resistor over the sum of the two resistors. So now let us assume that we're using that our same 1 kilo ohms. Let us do some little math. In 1 kilo ohms, that's our resistor. 1 kilo ohms. That's going to be what? 1000 ohms. Now let's assume we are using it in this formula. So we're going to R1 is 1000 because we're using the same value of resistor. So R1 times, but okay, let's continue. R1 times R2, that's going to be 1000 times 1000 over R2 plus R1. 1000 plus 1000. So 1000 times 1000, that's going to give us 1 million. 1, 2, 3, 4, 5, 6. Over 1000 plus 1000, that's going to give us what? 2000. Now let's do some little math. We're going to have 2 year 1, 2 year 500. Wow. So can you see what happened? We have two resistors. Our two resistors were what? 1 kilo ohms, 1 kilo ohms. But if we connect two of them in what? Parallel, what's going to happen? Total resistance is going to give us what? 500 ohms. Or the same thing as 0.5 kilo ohms. But these are just stories. Let us try it and see whether this mass is lying or not. So let us try it together. So can I try it now? Can I try it? Okay. So now let's try it. This is my multimeter here. This is my resistor. So let us measure my resistor individually. So now we have this. We have it as 0.9 human being imperfection, not giving us 1. Even though it says 1. So we have this also. Yeah, close to. So now, as I said earlier, let's assume this is P1, pin 2, P1, pin 2. So let's combine two of them together. The pin 1s are together. I mean the pin 2 are together. While the P1 also are together. So let's see if the mass is actually lined. Our calculation told us we're going to be getting to 500, okay, 500 or 0.5. So let's see. Wow. So the mass was even true. So can you see it now? Now we're getting what? 0.5 kilo ohms. Or yeah. Or let me put it in normal days. So I'm going to be getting 500. We're getting the same what? 0.5 kilo ohms. Let's say that if we add another resistor again, it's going to make the resistance to what? Reduce. If we add a resistor in parallel again, it's going to make the what? Total resistance to what? Reduce and reduce and reduce and reduce and reduce. So let's see it again. In parallel connection, we have it as what? 0.59 or so. So that is to tell you about the beauty of some boring calculations, even though they're true. So now that's to tell us that what we have two type of connections. We have them in what? Parallel, and we have them in series. And this math that might look boring, has been one of the greatest thing being used in the world of electronics, because you might be in a project now, and the project you are looking for, if after doing all your calculations you saw that the resistor that is going to fit it is 500 ohms, and you know, and you can't see resistor of 500 ohms. You're not thinking what to do. But due to this beautiful mathematics you know in your head, you might decide to connect to 1 kilo ohms resistor in what? Parallel. So but let us just stop there. Let us show another example again. I have another resistor which is 330 ohms. 330 ohms. So let us put it here. So as I'm doing the calculation, I'm going to also be saying something. Now, in electronics, if you look at it, you see how big that resistor is, but all electronics have a resistor. So now, how are those electronics, just watching calculation, how are those electronics that are very tiny, yes, they have resistor, but still the resistor is very big, how are they now fitting inside? Now we have some package of resistor, we have some ways they package a what resistor. We have the resistor packaging deep hole. That means when I mean deep hole, that means all those resistor that resistor I just showed you now, it has pins. You insert it inside your circuit, you stood it under. And we have another resistor called SMD. SMD. That means surface mounted device. Now those resistors. That resistor also, but they are very tiny. They are like chips. They are very tiny. They are only mounted on the circuit board. Those are called SMD, and that is what is common now. And those ones are very easy to even calculate without a what? Without using your multimeter. It has a code. We deal with it every day when we are fixing electronics. And it's also good to know the real value of resistor, because it helps in troubleshooting a circuit. For instance now, a resistor might be actually 1 kilo ohms, but due to the fact that I've already gotten damaged, the resistance might be like 10,000 ohms. But you don't know, you look at it that okay, my multimeter says 10,000 ohms, and it is 10,000 kilo ohms, is working. Whereas you don't know that that's the raw value, and that will be the main problem of your circuit. But with those SMD resistor, it's very easy to know them. But we're not dealing with troubleshooting now. So let's deal with the calculation of this guy. 33 times 33. 9, 9, 9, 9. We have 9, 18, 10, 89. Oh, 0, 0. So we have 108, 900. 330 plus 330, that is 660. Oh, cancel this. Oh, shit. 2 here, 33. 2 here, 5, 4, 4, 5. So 3 here, 11. 3 here, 1. Remainder 2, 8, 0, 1, 8, 15. So we have 11 in 1, 8, 15. 11, 1, 8, 15. And 1, 8, 15 divided by what? 11. You can give us what? 1, remainder 7, 6, 11 times 6. 11 times 6, 66. Remainder 5. Okay, 165 ohms. So if we connect 330 ohms in parallel connection, we're going to be having what? 165 ohms. But if we connect it in series, it's going to be what? 660. Now let's try it out. Now I have my 300 ohms here. No, I mean 330. Okay, this is my 330 ohms here. This resistor. If you can see it, they even have different color code. Although the camera might not be clear for you to see. Can you see this one color code? And look at this one color code. They're kind of different. So now I have two resistor here. And two of them are the same value. So let's do this one should give us something like 0.33. So we have 0.325 Oman imperfection again. The resistance is low. So and we have another one also which is also 330. But when I discussed about the component we should buy, I said that we should get 330 on 1 kilo ohms also. And this is 330. Now the first thing we want to do is to connect it in series. And if you connect it in series, we're going to be seeing close to 660, 650 ohms. This is in series. Oh shit. Oh my, okay, I'm coming. Okay, so now that we have it, and it's not about these beautiful components that it is very cheap to buy. Okay, I know that is closed, that's why it is losing and falling. So let's what we have. It's in series though. So now we have what? We have 640, 639, and so ohms. That's because of what is in what? Series. Now let's connect it in parallel. You can leave it like that also because I said it that the resistor does not have polarity. I was just using the P1, P2 as an illustration. You can connect it anyhow. Just make sure that these two guys are together and these two guys are also what? Together. So we're going to be having what our board say 165. Now let's try it. So now can we all see? It's in parallel now and we're having what? Close to 160 ohms. So can we see that the mass is not what is not lying? And also maybe in the next class, okay, in the next class we're going to be discussing about another component. So that is it. In a resistor, if it's connected in what? Series, the resistance is going to what? Increase. And if it's connected in parallel, the resistance is going to what? Reduce.